much for your kind invitation to present some of our latest results. And I would like to congratulate for the second edition of the Building Digital Twin International Congress. So my name is Valentina Janev. I'm senior researcher in the Mihajlo Pupin Institute, University of Belgrade, Serbia. I have structured the presentation as following. So first I will point to some European legislation, and then I will talk mainly about the interoperability and integration framework that we have developed in Platoon, but this approach has impact also on other European projects that are currently going on. And I would like to point some results from our use case, from our pilot from Serbia. So the Institute Mihajlo Pupin is a regional center of excellence in smart energy management, and this is a synergy project that is currently going on together with National University of Galway and Austrian Institute of Technology. And our institute is a provider of the solutions and also maintainer of the energy of many information systems in the energy sector in Serbia, maintaining and providing solutions for the dispatching centers in Serbia, supervision of transmission network, supervision of entire distribution network, and integrated monitoring and balancing in the Serbia, Montenegro, and Macedonia block. So all these energy solutions are provided by our institute. So you can find here some commercial link to commercial applications. So challenges that we are addressing in the recent European projects are the digitalization of the energy sector. So the problems with fragmentation of applications, and also the big data that is coming from a lot of Internet of Things devices that are connected to the grid, and also in the buildings, the Internet of Things and smart appliances. So, but the biggest challenge in energy domain is the integration of renewable energy sources. So related to all these challenges, many initiatives were and strategies or directives are coming from Europe. So the European Green Deal, then European Strategy for Data, NMP, Energy System Integration Strategy, Data Governance Act. But I would like to point to European Strategy for Data, because this strategy is a foundation for our work. So regarding the application of ontologies and semantic technologies for building European data spaces as one of the enablers for this initiative. Besides this, a lot of other tools are needed, so technology tools for data pooling and sharing, standards, and also governance mechanisms, and so on. We are following recommendations, and we would like to be compliant with smart grid architecture model when we are developing the solutions, and also because in the energy value chain, the actors have to communicate with each other. So the technology should enable multi-party data exchange. And here I would like to point to technologies and solutions from the International Data Space Association. So in our work, we are answering some research questions. The work is in the domain of innovation. So we are talking about interoperability, building a semantic layer on top of the SCADA system. So in our case in Serbia, we have a proprietary SCADA systems, and we are interested to know how this semantic layer should look like, which concepts and properties should be selected, which standards should be selected in order to communicate our SCADA system with the semantic layer and further on with the energy marketplace. So I would like here also to point to some of our latest research papers. One of them has gained a Best Paper Award last week at the International Semantic Intelligence Conference. So semantic models that we are applying and validating are SIM, so Common Information Model, SAREF, Smart Appliance Reference Ontology, SAREF for Energy, SIS, ontology developed in framework of the Smart Energy Aware System project, and also regarding the description of the data sets and services is the DCAT, so Data Catalog Vocabulary, that provides a common understanding of the classes and property, describe a catalog of datasets and data services. So methodology that we are following, first we have for each part of the energy value chain, we have first to do the analysis of the requirements. Is this the requirement the producer or it's a consumer? So which part of the energy value chain we are modeling. Then we have the design phase when we select the ontologies or the vocabularies that we would like to reuse. And then we have a knowledge graph specification phase when we build the transformation rules in order to build the semantic layer. And then we have these semantic technologies in actions when automating the semantic pipeline and developing the graphical user interfaces. So I would like to now to go on and present, I'm sorry, I'm late a little bit, 5 minutes, some results from the Platoon project. In Platoon project, we are building the digital ecosystem for energy. We are building digital platforms. And in one part of the platform and enablers of these platforms are the semantic layer, so interoperability. Then we have data governance that is based on industrial data space concept, and then data analytics toolbox and edge computing. This is the vision of this digital energy ecosystem. So you can see here, many platforms across Europe share the same architecture and here share the same semantic models. So here we have the knowledge base that is built based on standards that I have pointed out. So the semantic pipeline looks like this. So we have the SCADA data, we have the other data as databit that have to be integrated. We have to build the semantic metadata. So for the data sets and the services, we are describing the metadata in the form of catalog, data sets are in the form of catalogs. And then this with transformation rules, we are building this unified knowledge base that I showed. So after that, when the data sets are described and also annotated with these semantic models, then we can go on and explore the semantic layer. For example, here we have one use case about the photovoltaic, one use case about the wind production, one use case about the transmission data provided by ENSOE, and then weather data, and we can see that all these properties are interconnected in these data sets. So another tool that Systoscape is used here. So our partner Technische Information Bibliothek is mainly working on producing of this nice visualization, how, for example, the data sets from Serbia are has the same notations from the data sets provided in Spain or in France. Here, I would like to point to the architecture. As I mentioned, we are referring to the smart grid architecture model. This model has many layers, and on the right side is the architecture that is proposed, for example, in Platoon framework. And on top of this, so on top of this data, and data is annotated with, as I said, semantics, and describe its semantics, then we can run semantic tools. So for example, one of our applications is Energy Analytic Dashboard, and this dashboard is a visualization tool that allows us to retrieve data. So the tool is generic, can be used in any part of the energy value chain, not just in Serbia, but all over Europe. So I would like just to make conclusions about the interoperability and the data harmonization that we have made. So the data sets were described with, and arrived in different formats, and then using the standardized data models, we annotated, we described the data sets, and we devised or developed this semantic layer. And then I would like to say that the DCAT, so the vocabulary that is used is very important for establishing this machine readable description and automation of the processes in the energy sector. So thank you very much to your attention. I'm available for questions. I would like to point to other projects that are very important. For example, the NEON project, Next Generation Integrated Energy Services for Citizen Energy Communities, where the building optimization is very, we are referring challenges related to building optimization, and also Omega X, the project that started in May this year about orchestrating an interoperable, sovereign, federated, multi-vector energy data space built on open standards and ready for Gaia X. So thank you very much for your attention.